All right. I'll close a few of my files here. I'm going to close my assembly files of my. I'm just going to simplify my browser just a little bit here. Uh, and then, like I said, if you go into the resources section for the 3D car, you should. This model is even that you can pull it into Inventor and check it out if you want to.
That's what I've been doing.
Okay, cool, cool. Yeah, yeah. And if you need that over there longer, you can, dude. So,
No, it's good.
yeah, yeah, take off. Yeah. Okay.
Oh man, I need more time. There is no more time.
We all are give allotted the same amount of time each day. How we choose to use that time, I waste a lot of mine too.
If you're cutting on your sleep, then you would want.
Oh, that's true.
So I,
But you're more well rested. So yeah, it's true. That is true. I had insomnia and I finally have started to sleep good again. Now I can hardly get up. I think they say if you like jack up your sleep one day, I think the body doesn't really catch up for several days, right? Like, or technically you never can really catch up that. It's just like, yeah, you lose it forever and your brain is, yeah, that's true. That explains a lot of my problems. Um, so what do I have? I don't need that. I don't need that open anymore. So I've just got my three main assemblies open. The overall assembly with bearings, seal plates, gearbox, housing, screw. I've got my screw, and I've got this housing open now. So I just want to show you this. Is how to. So what we want to do is put some bolts in here, and I'm not gonna put bolts on everything. I'm just gonna put the bolts in the parts of this together. So really, that's just gonna be the end plate bolts onto these flanges. And then there's going to be bolts through here, but maybe I think I won't put those in until I put the piece that would go on there. And then I might put the bolts in whatever assembly I choose to do that at. And then I'm going to put bolts in here where the end plate bolts to this U-shaped flange here, my good luck flange, and put those in. And then not these ones here until I would have something that would bolt on there at that kind of assembly level. So what we can do for bolts is there should be a default library. I hope that everybody can access this. I'm not exactly sure, but I think it is. So I'm in this assembly. I'm going to go place, like I'm going to place my components, but I'm going to place from a content center. So when you and this should be, if you've downloaded these programs and you've just included all of the content stuff, which is probably 7 or 8 gigs. I don't know what it is, but because they are pretty big content centers. Um, then you should have access to this menu here. So if I say place from content center, it goes into this, and mine is going to go probably to not where yours is. Maybe mine's going to go to the last place I looked, which I don't know what that looks like actually. Does it look similar to what you? Oh yeah, so it's got this model browser over here. We have different types of this is just content that was loaded with Inventor that's probably just really commonly used stuff. Um, and so what I want to do is place fasteners in my yeah. So this fastener one is the one I want, which has bolts, nuts, pins, rivets, washers. But it's going to be pretty extensive. So what I'm looking to do is a bolt. I want to bolt the end plate onto the flanges that support it. And so I'm kind of expanding out here and driving down. I think if you select this, you can just start filtering it at that point as well. But here I can just get to their simplified. I'm looking for a hex head bolt. It's further expanding here. I think if I just select this though, yeah, I'm just gonna. I don't. Maybe I won't pick a self-tapping or sheet metal screws or a shoulder bolt, no, or a drilled shank. I'm actually just going to go to the hex head menu, and then it's a fairly expansive list of metric and standard, and just like walking into a hardware store, like, and that's one of my favorite places to hang out. I don't know why. I like fasteners, so some people like crayons. I like fasteners. Um, Yeah, they have tons here. So what all of them mean, even I don't know. There's so many pieces of hardware. What I'm looking for is just a simple, I think it's down here, middle of I'm just looking, and really I would need stainless, but I don't know if their content center has stainless. So I'm just going to forego that. I could pull that hardware from McMaster Carr as well, and it would be similar to what's going on here. But I wanted to show you if you have and you can load other hardware into the content center. It's just kind of a library. And so if the fasteners you don't have are here, you could technically load your own fasteners, and you can even build your own I mean, you could like companies will build their own maybe normal used fastener library rather than have everybody have to dig through all this stuff that we're never going to use. Some people prefer to make their content centers. Companies definitely, it's that library dude in the or person in the whoever the design manager decides has to manage their libraries. Um, they will build out ideally if they were trying to become efficient and lean manufacturing type thinking. I just want the hardware that I use in my at my company, which can still be hundreds of pieces of hardware, but I don't need to surf through all this stuff that doesn't apply. Um, so hex head inch is all I want. So I don't know that's clear down here, and I don't know how far down it is. A third of the way down through, kind of just hiding in here. It's just kind of the most simple description here. A hex head inch bolt is what I'm looking for. So I'm going to select this, and then it just goes right to like, okay, go ahead and place this. So I'll go into that again, but it's like I'm placing from content center. I'm getting into the content center. I kind of expanded the fasteners, bolts, and I just selected hex head, so it brings up all the different hex head bolts that are available. And then I just perused down through. I didn't want any of this metric stuff or this real specific stuff. I just scanned down until I saw the simplest description here. Hex head or hex bolt in the inch size. Yeah, when you select this, or maybe you have to double click on it, it goes right back to your model and is ready to put it in because it's going to be able to recognize feature size in our assembly and recognize the bolts that will fit into this. So what I'm going to do is now pick either end here. I'm on my drive end, and the bolts I'm trying to install are these ones here that would go through here. And or it goes through here, right? It's like I have to choose because what I have, if you look at it, I've got a bolt head here, and it's going to I've kind of got control of it at the inside or the inside of the head is where I've got control. So it wants me to pick it's kind of an insert, constraint type command here. It wants you to pick an edge of a face that you want to align this bolt into. So it is kind of doing an insert constraint on this. And so you kind of have to think about, well, which way do you want your head? You have to, yeah. Does your head, do you want to, yeah, it just matters. Like which way do you want the head or which way do you want the nut? This is going to be a bolt and a nut combination here. And so you could pick here, but that would put your head on the inside here and the nut on the outside. I'm going to pick here because it's more of a finish pro. I think when you put in fasteners on equipment, you kind of think, what is your finish? What is the outside finish? And that might be where the head goes on a fastener. Uh, and so to me, this is kind of the outermost part where, like, as this is my this is as artistic as you get with mechanical design. Is like the an artist thinks of all these beautiful things, or what I think of like, okay, which way do I want my fastener head to be in my assembly? To me, this would make the most logical sense. And it would look good. The nut's kind of hidden behind in the flange area. It's not hidden, but it's just not the primary thing I see. There's reasons for going either way, but I'm going to pick this edge here, and it's already it can already show up that it's saying, hey, I think I'm going to put a 3/8 by 16 thread in there. That little description's kind of showing up, and it's a 1/2 inch long. That may not be as long as I need, but I can define this a little bit later. Mostly, I just need you to select an edge of where this goes. And then it brings up a mini little dialog box. It's super powerful. So if I just hover over these, this is to lock rotation. So if you think of like an insert command, so it'll still allow the thing to spin. It'll insert and do an axial alignment to a face to face, but it still allows it to spin. And so it's not going to matter to me in this case, but sometimes I might just want to lock the rotation of this so that however the head is, I can't sit there and spin the head. If I don't select this, I'll be able to actually spin the bolt in the hole, which may or may not matter. I'm going to say it doesn't matter for me. The next selection is insert multiple, and it already has recognized, this is to where when I think of like AI affecting art, well, maybe this is some program, they wrote some code here or had AI write some code that says if because this face has all these features that are similar, I can recognize them. And so do you want me to just insert all of these? And it's like, yeah, I kind of do. So I want that one checked. If you uncheck this, it's just gonna maintain the only the one that you've selected. So if you select this, it's gonna do its best to guess what those ones are, and I think it does a real good job. Those are the ones I want. It didn't pick these ones. But yeah, I think you could go through here and pick others as well. So I think I could even do this on the end plate over here. But maybe not. Maybe I'll do this as a separate step. So let's just stick with this simple, keep it simple. So it's selecting all those, which is the ones I want to do. If I move next, it's grayed out. It won't let me do whatever this is. But this one here is is a bolted connection. So it's just going to bring up another dialog box. If I don't want a bolted connection, it'll just put in the bolts that I choose here. Or, it'll choose it. Yeah, it'll just be like, okay, I'll just put in the bolt. I want to do a bolted connection because I want a nut on the other side of this. So I'm going to say, actually, what I have going on in this situation, I've already got my materials, I've got my assembly, I got a good idea of how long of a bolt I need with a nut on it. So I'm going to say I want a bolted connection. And I think the next error over was just to accept what you did. But because I've chose bolted connection, I went into another subcategory here where, let's see if I sometimes fumble with this a little bit because I don't use it. I haven't used it since my career a few years ago. But let's see. Yes, I want it to be concentrically. Bolt to hole that I've picked to be concentric. I could choose different configurations there. I'm going to say concentric. It's already picking that this is a half-inch long. If I even look at kind of the witness or the ghosting of how it's not going to be long enough to put a nut on it and thread the entire nut. It's barely protruding through the two pieces of plate. So this is not long enough, but I think I don't have to worry about it. The start plane. Oh, and then the termination. So I think it already knows the start plane. If I select this again, I think I could maybe I can select this again and say this is the start plane, and then where eight circle references termination. Maybe I don't need to pick that actually. Maybe I wanted to pick termination point. Maybe I'll just cancel this really quick and go back into it because I can't remember how to get. Let me just cancel. I'll pick my content center part again. It's a little bit annoying, but that's the one I want. This is the hole. It's a bolted connection. If I pick I think what it's saying is I already know all this information. Sorry, I shouldn't have chose that. Kind of messed me up. Termination is the next thing that it wants to select. And so now I'm going to select this face because this is the active icon now in my bolted connection. The other two have already been determined. That one, now it knows, okay, at least it pushed me a little bit longer. Now it's a 5/8 long bolt. And then if I say I'm going to add a fastener, though, which is what I want to do, I want to add a nut to the other side of this. Um, some people might be saying, well, how come I'm not using washers and then bolt and nut, or, bolt and a washer and a nut are kind of a real common uh, configuration of, yeah, a little packaged fastener configuration. And so the only reason why I need to use generally washers is sometimes because I'm looking to like uh, perfectly establish a nice plane for the underside of the head and maybe the underside of the nut to seal down to. If I feel like in this case, I can just say the head is going to go right up against my plate. Some people will use washers because they have an excessively large hole, and then the either the nut or the bolt head will kind of like not seat really nice against a flat surface, so they use a washer for that. That would not be a great thing. When I have control over design, I don't like excessively large holes. That's why using those clearance hole commands is really critical.
Would just be to protect the art.
For marring, maybe.
Yeah.
Yeah. So that head doesn't like spin into the material and scratch the heck out of it. So you kind of, yeah, I agree with that. In the food processing world, they hate washers because when I take apart this assembly, if I drop washers and they fall into, and I might not notice where they fell or can't find them, they fell into some other equipment. It's just I have that problem with the nut and the bolt itself already. But if I'm adding like extra washers, it's just more parts that I can lose track of. And so, like food processing likes to eliminate washer type connections. Um, so. I think if I went to add a fastener here, though, I think it is going to consider that the next fastener in the assembly would be a washer. And so I think I can skip that one and say like, well, I don't want to do, or let me see here. Yeah, I'm not picking. So I think I can say, actually, I'll go back, I'll click on this dialog box and say, I didn't want to add the washer. I wanted to add, I'll click the next one down here. And I think this one has a drop down menu. You can say like, well, what are you adding? which seems like it's kind of the third one in the sequence, but it's like I'm not doing a washer, which I think is the only thing you have access to on the second fastener. Here, I finally get into the nut. I'm going to say yes. I don't want to put anything here. I just want to put the nut.
You have to click on the next one down.
Yeah, I'll come back to here. So all I've really done is, pick the termination face. And now I'm skipping this one because it just doesn't have the selection for it. It really wants to be washer driven as the next fastener. I'm going to skip that and say, well, this one here gives me a little, yeah, it's like 4 drop downs in here, right? Nuts, sheet metal nuts, and washers. I'm just going to pick a regular nut. Technically, in my mind, I don't even know what the difference they consider a sheet metal nut. I mean, I might, if I look at them, they might have a little lower profile or something. They might have a little flange on it. I think I can still select that from here, even though if I pick nuts here, it's going to be this mini box that has a gigantic amount of options here. So there is flange nuts in here as well, huh? And you know who I saw really common using flange nuts was any European built equipment that I was, German made. Um, they seem to love flange nuts. And I think they are really nice. What I'm going to tell you that food processing likes is like what we call like a torque type nut. I can't say for sure. I'm going to pick. So I've got this is like maybe more common ones. This would be the most pretty much generic, general type of nut, just a hex nut. Jam nuts are a thinner profile nut, and they have a specific. Sometimes you have to what we call like double nut, like a fastener. It's almost to hold the. It's used in a lot of different applications, but they are a thinner profile and for a specific reason. Then we have big, thick, heavy duty stuff. Other jam nuts. Looks like what I want to pick is this prevailing torque type hex nut. I've seen Europeans like to use these crown type nuts as well. These little, yeah. So, and then there's other ones. Maybe they call these like castle nuts. Yeah. And then these ones are yeah, these are a wing nuts. Yeah. I want this prevailing torque. What it has is it has a, if I'm thinking of it right, we would call them Nylox nuts. And I can't say this is exactly what this is, but it kind of is the idea is there's a little nylon piece of material in the end of this nut that acts as kind of a locking mechanism because it isn't cut with the threads. And so as you actually drive this nut on, it'll cut the threads into the nylon and it kind of acts as instead of using like a lock washer, which is a split washer that kind of acts as a locking mechanism. It's like as the torque compresses the lock washer. If you've ever seen those washers, they're kind of split and open. It really is designed to kind of be a locking mechanism. That compression of that split kind of helps lock. It's like it makes you have to torque down with compression to make everything fit nice and tight. And it does prevent it from being able to sometimes back itself off. Because nuts are famous for as vibration happens in equipment, eventually that's why torque specs on nuts and fasteners are so critical because as vibration happens, if you don't have things torqued down at their engineered design, they can eventually vibrations can rattle those loose. Even with things torqued down, it can still sometimes rattle loose given the amount of time. Like, years and years later, finally some nuts are starting to come loose or whatever. The torque nuts tend to, these kind of Nylox nuts tend to prevent that. So I'm going to pick this one. And then it adds it to that face where I terminated. And then it even extended my bolts just a little bit longer to go, my favorite term is proud the nut. You want your fasteners to be proud of the nut. They need to cut through the nut, not overly. Like if you have too much over there, it's just excessive length that's unnecessary. And in a food processing world, it's threaded and it's dirty anyway. So I like that this content center just is kind of helping me determine some of those things based off my parameters that I pick. And so I'm going to say, yes, I want to add nuts. This is a bolt. This is essentially is what I want to do is just like that. It's going to be a 3/8 by 16 unified national course, 1 inch long, and it's going to have this little torque type hex nut on it. And so I'm just going to say, okay, now. And then it should apply those to it. And that kind of gives you an idea of what that nut looks like. Yeah. But there's just a myriad of combinations I could do for fasteners. I mean, you can see how many different fasteners I have and different types of how they terminate or what kind of fasteners go with them. This is kind of a simple, kind of in a food processing realm application right here. I've got nice, clearance holes. They're not excessively large for the nut, the faces of the bolt or the nut to seat against the plates. But yeah, so this is just simple. Yeah, so then what you'll notice is on your model browser, this is the disadvantage of this kind of a thing. If I collapse all, it just gave me a bazillion individual, which is nice because I can sometimes manage these individually. Well, let's create one. Good point. Let's put a folder in there, right? So I should be able to add a folder here, right? How do I do this? Do I double click, right click in here somewhere? Yeah. Do I do the right click?
Yeah, it's trying to.
Create new folder. That's exactly what I want to do. Because this is common with me. If I'm using this content center type, this makes a mess out of my model browser. So I'm going to make a fastener folder. And so um, we will create new folder. I'm just going to give it a name like fasteners or fastener. Fastener, fastener. You could put hardware, you could put bolts. I don't know. Fasteners is what maybe I'm going to use. I'm going to drag this thing up to the top. And sometimes I put these like right below my origin. I might have my subfolders here. And then you can just shift select these all. Here's all of these. I think I can just like, yeah, shift select them all
Just
from that as well. This is this is how I buried mine in there. So now I've at least got, and this is going to become longer. Some assemblies become very long. Some people will prefer not to use that just because you could make this a smaller menu too. If you actually just inserted one and then did a pattern that thing through my part, it actually would be condensed more in the menu because they would become like a component of a pattern, and they kind of and those simplify model browsers. Some people prefer that. Some people prefer just to have a big wrap sheet of the all the fasteners. So and sometimes I'll do either one. There might be some situations where I'm like, I don't love the patterning it's doing. I'll just do my own pattern and just put the one bolted connection in and then pattern that feature how I want it to be. So yeah, sometimes the content center uh, is and to use the bolted connection and to let it recognize is great. So I'll do it again on this side for these. I need to bolt all these ones on, and it will figure the same way here. Yeah. So let's just do that one more time. Place from content center. It's probably going to drive down to where you were last. Mine is. That's what I want to place. And then I'll just pick a hole here. It recognizes it. I want to do it as a bolted connection. I'm going to pick the same thing essentially. So just the termination is the other side of my flange, like that. And then I can add my fastener now that it knows where to terminate it, I think. Yeah, second fastener down for the nut and for that prevailing torque type hex nut in inches. And then it looks like it came up with the same fastener. That's great. And and it's recognizing that whole pattern around that. That's great. And so I'll say, okay. And wait, could I have picked a menu? I don't know. I'll just move it again. I'll just do my ship. The prevailing torque type nuts. Yeah. Yeah. And whether that's stainless or not, I don't know. Like if I maybe have to, it says mild steel. So that is not what I would not want. I just don't think there's any stainless type. And at least as I previewed it, I didn't notice it. But I'm dragging and dropping these into my fastener area as well. So I've got a big fastener submenu. And that's not the only thing we need. We need a stud to hold on the bearing. So we could go ahead and get an idea, but yeah, so I can jump over to this because this has me an idea of how long of a fastener I need. It's got to go. And I don't use the stud. We're gonna try it, but we'll see how it works. I'm just gonna get an idea of like this stud isn't gonna it isn't this is threaded. We've designed this to be threaded, and so and then what we're going to do is we're actually going to thread in a stud and kind of use it like we did here. We're going to make a plug weld area here. So what we're going to do is we're going to have our technicians like thread in a stud, and a stud is a headless kind of bolt. It doesn't have a head on either end. And so it's going to be able to like thread into this about, halfway or a little more than halfway and leave a depression like this in it. and then I'm gonna have the welders weld that stud in here. And so there's no head on the inside of my housing. It's just kind of a plug weld I'll see there. And then it needs to protrude through all the way out to here and then have a fastener on this end. So I might have to do this in a couple steps in the content center, but I'm just going to get an idea of from this face to this face how far this is. So it's like 1.9375. That's 1 and 15 sixteenths. 0.9375 is 15 sixteenths. So that's how far it would have to be to clear, and then it's going to be longer than that to go through a nut and stuff. So I might have to I'm going to take a guess. At least needs to be, I'll say it's 2 inches. At least needs to be 2 inches, and then I'll fine tune the length out here. So let's go back to this assembly though. Where I want to put that in is right here. I could put it in here as well, but I have some thoughts about where to put this in, and I think this is a great place to put this in. So I'm going to say place from content center. I'm in the head, I'm in the on the fasteners tab. Instead of being a hex head here, they have a stud one right here. Studs. And let me just see what I haven't done this on my assembly yet to see if I even have something that's going to work for me. I'm just looking for kind of a regular mm,
So studs and mechanical are these.
yeah, this is considered a stud. These are mechanical stud. And I have a lot of different options here. So I was just perusing through it. I don't want DIN. I don't know. A and B makes me think of a classification. I'd have to do a little research on which one I might want here. But how about we do this? How about we just make our own? Let's do it. And we can make it stainless steel. So what I'm gonna do is I'm gonna jump out to a part. I think I can do this quick. Let's see if I can. So I'm gonna go out to a new part. Browse. Just a new standard part. An English standard part. Create. And what I want to do is I just want to create, I want to use this thread command on the modify palette. So what I want to do is just build a build a rod that I can thread the outside of it. And so if I do that, and what I have going, because I have a couple different needs on this assembly. On the driven end, I believe these are this is for 5/8 hardware. If I don't remember that, I could open up this end plate here and go into I think where I put those in was actually even down deeper. Open the base component. So I'm just driving down clear to where this part came from and where that hole was determined. If I can't remember. That hole. What is it? It was for a 5/8 bolt. Yep. I've got it as a 5/8 11 UNC is what I was at this design stage here. So I'll jump back over to that part to this part that I created that I haven't even named or done anything with. And I'm just gonna do like I'm gonna start a sketch on just the XY plane, I think. XY plane, new sketch. I'm gonna do a simple circle that is I'll make it 0.625. That's the size of the bolt and the thread and the holes. Let me just see if that'll work. 0.625. I've got it constrained to the center. I'll jump back out. I said I need to make it about 2 inches and longer than that, actually. So I could take a guess here, but what I'm going to do is I'm going to say extrude this thing. And I can just extrude it from one direction. Doesn't matter to me which direction I go, away from my sketch or towards it or in it. At least 2 inches. It was like 1 and 15 sixteenths to get through. And maybe I'll say, oh, I don't know. Let's do it. I know I need to put a nut on it to hold it on. So let's just say 2.5, 2.5 inches. This is just me, not 22 and a half, by the way. 2.5 inches of a little rod here like this. And I'm gonna say, okay. And I'll go ahead and change this to stainless steel. This would be a stainless steel. I know that our fasteners are probably not, but this one's gonna be stainless. And technically, remember, the fastener should be stainless on that stainless assembly. A mild steel one would be even a zinc plated one would be not a good combo in a food processing environment. So, and then I'm going to thread this, see if I can thread this with this thread command. Thread this surface. I think it already recognizes it. If I've I've kind of picked the major diameter to design to, and now when I pick this surface, to me, is this what you guys are getting? Like it's preloading what it thinks it is? Yeah, the closer you kind of design your size here, the closer it will guess more correct. And I think you have to be within a threshold, otherwise it'll say, I can't do it. You've got to make your extrusion bigger or something to do it. If I try to do like a 3/8 one, it might tell me your original extrusion is kind of too big for that. But if you get it close, I think of picking the major diameter. So that's why it kind of recognize, which is I'm glad. And it's a right hand thread for sure. Left hand threads are unusual on everything. So okay. One note for me that I've learned kind of the hard way is I'm used to doing this kind of work, and so that my drafting calls out these threads. I can just use when I get into my drawing and point to this, it'll recognize the thread, and I draft that way. Um, if you 3D print, it does not recognize this kind of stuff. If you were to export this file as an STL file, it would just be a smooth rod. So Inventor's weird. It does that. I don't know why. I'm waiting for them to develop that to where there's just like in this dialog box of this thread. I'm going to show you something. Like it does show to display the thread in model, but in technicality, it doesn't have all the G code data in this model, even though it can pull up a quick representation and I can totally, as a drafter, point to that and it will recognize that is the thread. And but if you want to 3D print this, you have to do this like we did our screw. You need to do like a helical sketch and define it that way. And so you'd actually use kind of how we did our flights on the screw. Use the helical option to define the threads that will actually show up in an STL file. I wasn't aware of that till I started trying to print more threads. And I was like, wait, why are my STL files already solid? Oh, I actually have to design the thread. So it's a little bit more labor intensive that way. It actually does. Oh yeah, that's good. Inventors, they haven't come that way yet. At least I haven't found that they've added. I expect them one day to add that in here, another dialog box that says include threads in STL file or something that they programmed into it.
Warning that it's like nominal ideal size or something, like do not use this for the actual production or something.
I got you because it's just not it's they want you to use that, yeah, because and that's smart, like yeah, what Nathan's saying is, and what I'm used to is in a real environment, like on our end plates when we need to thread them, we would not want those to be maybe printed or additive manufacturing made. We would prefer those to probably be cut with a tool because threads are so critical if to design, to hold the load. And so generally plastic threads aren't going to be super strong anyway, but well, technically I think they're pretty strong for a lot of applications, but yeah, the funny thing is if you go to buy, like if you go to a hardware aisle and you like dig through bolts, the nylon fasteners are 4 times the money. And you're thinking they're just like a 3D printed part. That steel fastener seems like it should be more expensive. No, the nylon fasteners are actually kind of expensive. So I'm just gonna say okay on that. And now I've got a little threaded rod that is and I think I can chamfer this too. So I might put a little chamfer on the end of here. Just like a 30 seconds, like 0.03125 on the ends of this thing here. That just helps. Why you would do this is because who's maybe going to make this is we might be able to buy one and that's already cut to this length once I define what the length is and source it that way, like you would a piece like a bolt. But sometimes companies will just buy this in like 10-foot sticks of threaded rod and they will cut these to their size, kind of like my weights that we're cutting for our car. You can buy this in super long lengths and just cut your own threads. Once they cut them, they need to kind of take them on a sander and deburr the edge a little bit here so that you can actually start the thread. So to have a real square cutoff doesn't always let you thread that into. And you'll notice on bolted hard, if you look at them, they have a little chamfer on their edge usually. So if I say I'm going to chamfer that edge, that's a little more of a finished detail of what that would look like. I just need to give this a name. So this is my next part. Save it in my part. Yeah, this is going to be a part in my part folder. My next one is 25. So I've got part 25. And I think I'm going to go and insert this into this assembly right here, where I put in my bolts. So now I'm going to place from my, I know I got just a little more time. I'm going to get it, I promise. Here we go. Oh yeah, I'm going to place, oh yeah, not my assembly, but I'm going to place that little part I made right there. Open it up. And I'll just place that in. That is not the drive end one though, by the way. That is the driven end one. Oh, and I'm on the driven end. Perfectly placed, actually. That's that hole. This hole over here is smaller. I think it's for 7/16 hardware, if I remember right. So I can't use this on both ends. But what I'm going to do is just do that insert command here. Insert this, and I'm going to pick this where my littlest part of my chamfer there, the outermost face and edge here, that face, edge, and axis. And I'm going to insert that into my end plate. I'm going to insert it to the inside. I want it to actually thread through here, and then I want it to go to here. Of course, I want it to go that way. Yeah, that's actually the inside of my end plate there. Yes. Because what I'm doing is I'm threading that in all the way. This would be flush finished. And some people model this way that if a welder's really going to weld that, they're gonna probably put an offset in there about like maybe an eighth of an inch offset. So they're only going to thread it in like that far, so they can do a plug weld like they would do on that screw pin that we did. We have a little depression that we can fill up with weld, fill it up to where it's at least flush to the surface there. So I put an eighth of an inch offset in there. I'm gonna say okay. Yeah, I did an eighth, because then it looks like this. It gives me a little bit of a plug weld for a welder. But some places might say, "Oh, don't do that because we don't know if that's how much they're going to actually thread it in." And like this is a really minute detail. I actually just did one. That's just insert. Yeah, 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 yeah. This thing, yeah, because it'll still spin. Yeah, so it's just insert with those correct faces and offset an eighth of an inch, 0.125. And now I'm going to pattern that. So this is what I said. You could do like with a single bolt assembly, you could just place one and then pattern it how you want it. So I'm just going to pattern this particular. So I think I'm on the assemble tab in this pattern. And I'm going to pick this pattern. And then I can just pick how I want to pattern it. Well, I'll do a rectangular pattern here. So pick your columns and rows. My column direction. When I do this, you can pick the origin like planes if you want, or axes. Or you could pick a part or an edge. Just remember that if you pick something like this, it's a constraint that like if this edge ever changes on this part, that's how you're driving this pattern. So if you want to stay safe or not have this ever blow up, you can pick the axis in the column direction that I want to go, which to me is the x-axis. And of course, it's going to throw one in that way. I want to reverse that direction, flip direction. I'm going to go this way, and then I need to go from center to center is how far it is. It's already given me two of them at 2 inches as default. So here, remember, you can I can do a measurement here. If you click this little side menu, you can measure the distance you really want. That's what I'm going to do. I'm going to measure. So I'm just measuring now. From here, I'm going to pick I could pick where I'm at, but I have nobody in my way here. So I'm going to pick like here, like the bore of this. We'll pick up the axis. So I'm measuring from here to here, this bore to this bore. And it'll pick this up as 4.59. That does not seem correct. Did I not get rid of some information here? What the heck? Let me try again. Wait. Let's try again. Measure. Maybe I need to. This is one other thing to remember. When you pick something like this, if you right click, there's a select other. If I do this, you get a mini little menu that fades on you fast. But here I can pick different features, based off the geometry I selected. Here's other features that I can get to. Really what I want is the axis. And then I'm going to come over here. I'll do it again, by the way. So I come in here and I kind of hover over the geometry that I'm really looking for. But then before I left click, I right click and I select other from this menu. And then this little thing will fade fast. If you get off it, it just fades. And you're like, wait. So it's kind of annoying. If it fades on you, just come back to it, right click, select other, get to this menu where you can drop down. It only recognizes that as a face to face, interestingly. I thought I'd have an axis there.
Do the circular pattern, I think like one second.
If you do the circular pattern, you could do circular pattern and then it would just be the circular driven at this, yeah, diameter. That's not bad either. I love it. You have to think circular or think rectangular. I'll keep doing mine. Technically my thing should be, I don't know, axis to axis.
How do you do it circular?
I actually got it though on mine.
Good pattern. Now, like the other circle as the direction of rotation.
Middle one.
Yeah.
Are you correct? You can sit up.
Yeah, there we go. Love that.
And I was just afraid like, what if time changed? Will be ventured.
Yeah, I totally like as long as you're kind of planning for the future, everything can be modified later. I'm actually selecting these now. Just remember that this is something I think people forget a lot is that you have once you've selected geometry, you have options for the, picking what exactly from that geometry are you trying to align to. So I've just picked rows and columns. It ends up being a what? A 5.126 is what it's interpreting that as. And then I need to jump out to this assembly really quick, and that's how far it goes through. Let me update it. Oh, sorry, I'm looking at the wrong end. Let me go to this end. Technically, I'm probably wrong because I measured the wrong side for the side that I actually built, which is okay because I'm just going to go in and change that overall length. But I'm going to add the nut here first, I think. So this is where, it's I would add probably the nut here because you're going to have a nice place to add it to where it's actually going to go on that bearing. So this is going to become like in this assembly, if I think about how my parts list is going to be generated in this assembly, wherever that assembly is, that one, this, when you guys open up your drawings, it'll have like new parts in your parts list now because you've added parts here. So you have to add new balloons to it and you'll have to identify these studs and their length and stuff and probably add a detail sheet of that. So it's a part that they know they have to get. With the fasteners, you don't usually add detail sheets for the fastener. A simple call out on the print, point to it, and then let the parts list. Yeah, totally. It'll add that to your parts list. So that'll be where they'll order that from your parts list. It's just an ordered part. So here, I just need to determine what the length will be. So what I'm going to say is I'm going to add the nut in this assembly, but that could be debated. Some people might prefer to put it on there and have figured out where it goes. But I think I'll just add it here because I have the constraints I need to use. So I'm going to say assemble, place from content center. It's just a nut this time, not the, I don't need the hex head bolt. So I think nuts are down here in the fasteners, bolts. I'm not doing bolts. I'm going to do nuts. So I can just pick the nuts and I should have, I think it should be under the hex category. Yeah. Oh yeah. Look at all those things. I'm looking for that same type of nut that I used before. Oh, right there, the prevailing torque head nut. Yeah, in the inch. This one must be. I think this one is inch. Yes. Yeah, I think that's the one I want. I can double click on it. Then I'm just going to double click this to 5/8 11. Yeah, that's the right one. I'm going to put that on right there. I select that. It will also recognize all four. I only need the nut, so I do want it to select all of them. I don't need a bolted connection. It doesn't even give me that option because I didn't put a bolt in first. So I think I can just hit OK on this. The other one is to place, finish the current insertion and stop inserting, or I think does this allow you to go into another? Yeah, so technically I'm kind of done with this one here.
No, it's okay. Not too good. I was like, why are they?
Yeah. And now what I'm going to say is generally the length that you need to be proud the nut is maybe just a couple of threads. If you kind of see here how much they've done it, maybe it looks like about 2 threads that are proud. I don't know what this overall dimension is. Let me just check it. From here to here, the configurator kind of gave us 0.1475 through there. So I mean, I could do the same amount here, or I don't know how far two threads are. Your threads are always going to vary on the size. So I do like the idea of two threads. So this is a little bit larger size than that one, but I don't know. Maybe I'll use about the same dimension, a little longer than an eighth of an inch, not quite 3/16, somewhere between an eighth and 3/16, 1475. So really, I want to just figure out what the difference of those two is. 1475. So I'm going to measure. I'm just going to do a quick measurement of what they've actually given me. What is it? 0.455. Yeah, it's a little excessive. Is it 0.4? Sorry, forgot. 0.455. Was it 1475? Ooh, I don't know if that was exactly right. Hmm. Yeah, I need to cut about 3.3075 off my overall length of that part of my stud. So I'll just go in there and say I'm going to cut off 0.3. That's easy. 0.3 less on that little part. Where's my little part? I still have it open. That one. So it's my original extrusion. I'm going to edit. It was 2.5 minus 0.3. I could go figure that out in my calculator, but it would be 2.2? Does that sound right? Looks right to me. 2.2 instead of 2.5. Maybe 2.25 would be great, little round number, but we'll go 2.2. Now when I jump back out to this assembly, I hope that I see that looks pretty good. And now that thing will actually stay in position. I got to do the same thing on the I'll stop now, but I need to do the same thing on this end. It's and I would take and make a copy of that stud here and then make the size smaller. It's a 7/16 hardware on the end, so I'd probably go into that original sketch on that, make a copy of this stud on the original sketch, go make it 0.4375, and then that'll be the right size of threads. And then I'd go insert it in the assembly, and then I'm gonna have to check the length of it, and probably it's not gonna be this length, probably gonna be a different length. So I'll just need a copy of that part. And then, yeah. So I didn't get to my drawings, but I will. I'm gonna actually open them up and start working on them this afternoon after I finish doing the grading on your portfolio drawings. I'm gonna go in and open, and so I will still post them. Like if you want to check back in later tomorrow afternoon, I hope by then you should see my conveyor assembly, or sorry, the screw itself, the assembly drawings beginning. And I'll open them as a new drawing set, like I said before. I'm not gonna add them to that other drawing set yet. I'm gonna just detail the screw itself. And I might open up my old drawings that you have, because you'll end up having some new parts that have showed up in your old drawings now. And so they'll want to update, and you'll want to balloon those parts on those old drawings. And but I'm not going to combine the two drawing sets yet, but I could do some updates on them. And your screw drawings will be a little simpler, actually. I mean, it is just this assembly somewhere right here. So it's going to have the flights. And just so you know, I'm not going to detail out the flight like on its own, like part of the assembly. I'm going to do a local note call out on the assembly drawing, and I'm going to call out all of the details of the flight. I'm going to say, it's, a 10-inch OD flight. It's got a 1 3/8 or a 2-inch, you can just say a 2-inch Schedule 40 center pipe, and that it's a full pitch, or a 10-inch pitch. It's just and it's made out of the material that it's made out of. I can't remember, is it 10 gauge on ours? Yeah, 10 gauge. So I'm going to make a local note, just a leader line local note on the assembly print, and it's going to have all of those details. And I will have the cut file of it, because we developed a flat pattern for it. So it will have a cut file part that says quantity 9. And but I'm not going to actually do like a part detail of it. It's just kind of complex. I'm going to handle the details of it with just the local note. And then whoever has to press those flights will just follow my local note, stainless steel 10 gauge. And those, the diameter and the diameter of the center pipe and the pitch of it is going to be the information they need to know. And they can press them for this. So yeah, look for that. I will post it up by tomorrow. We can work on it a little bit next week too. And that's the last kind of drawing set I wanted to finish, kind of. Like there might be a little work next week just finishing our drawings, which would be, I feel like if we get to the stage of here, um, and I have a drawing that captures this, it would be a great little portfolio item. It's like, hey, we got this far on a screw conveyor. It's super dangerous still. We didn't put lids on it yet, but yeah, it's
Warning.
warning, not ready for production yet. Well, it might be ready for production, but not ready for operation yet. We could send some of this down and they could start building some of this, but we got more parts to do to it. So, and I'll do a few more as informational only next week. I'll mainly focus next week on making sure my drawings are done for these two assignments that I already have. And that's it, you guys. Let's call it. Yes, totally.
Oh, no, I was gonna